Okay, imagine trying to redesign a $1 billion factory floor, or, I don't know, rerouting an entire national rail network. One wrong move, and you've literally lost millions. Or worse, you've compromised physical safety. In this explainer, we are diving into a really fascinating shift in how modern organizations master that kind of chaos. Today, we're looking at how massive companies optimize their most complex operations without risking a single dollar of real-world capital. We are talking about the absolute game changer that is simulation modeling.
So it brings up a massive question, right? How do you predict the future without risking it all? Because experimenting in real life, whether you're overhauling a healthcare facility or managing some huge global supply chain, is incredibly risky and, let's be honest, unbelievably expensive. But today, we're going to show you a way to test those high-stakes business decisions in a completely safe, almost God mode digital environment. Here's a quick roadmap for our explainer today. We'll start with the core concepts of simulating the future, then we'll unpack the AnyLogic toolkit, learn a few masterclass rules from top developers, dive into a high-stakes Brazilian railway case study, and wrap up with how teams build these massive models together. All right, let's jump right into Section 1, simulating the future, and really why static formulas just aren't enough anymore. Think about your traditional Excel spreadsheets for a second. They are strictly formula-based. If you try modeling a highly dynamic, chaotic system in Excel, the sheets just quickly become this unmanageable mess of static data. Now compare that to an AnyLogic simulation. It's an interactive, risk-free environment with dynamic animation. Honestly, it is essentially a video game for business. It lets you test changes at any level of detail without breaking a single formula.
So at its core, a simulation model gives you a flexible, cost-efficient sandbox. It's basically a digital twin of your business. This lets organizations find bottlenecks, cut waste, and literally forecast market trends before they ever happen in the physical world. It's all about having the power to safely play out those massive what-ifs.
Moving right along to Section 2, the AnyLogic toolkit. One platform, multiple methods. Let's see how this software actually adapts to almost any business challenge. You know, the sheer versatility here is staggering. We're talking about managing patient flow in healthcare, routing global logistics, or even figuring out how to integrate renewable energy into power grids. AnyLogic is an indispensable asset because it allows organizations to create highly adaptable models tailored perfectly to their own unique friction points, no matter the industry. And it manages all that versatility by seamlessly integrating three core methodologies. You've got discrete event simulation for things like step-by-step factory lines, then agent-based modeling for tracking individual entities. Think of a single retail customer wandering through a store. And finally, system dynamics for those big picture market-wide forces. By combining these, you can zoom way in on a single train car and then zoom out to capture macroscopic dependencies, all in the exact same environment. Okay, Section 3, the masterclass rules. Expert strategies for building great models. Now we know what the tool is, let's look at how to actually build these systems, using philosophies straight from an AnyLogic masterclass. We have to start by talking about model purpose. There's this brilliant quote from Ben, who is an AnyLogic expert and an aerospace engineer. He points out that when you learn to fly, if you close your eyes while an airplane slowly banks, you literally won't feel the turn until you're suddenly looking straight down at the ground. And that perfectly captures the silent danger of what we call purpose drift. You add one tiny feature for a client, right? Then another, and suddenly your simple prediction tool has bloated into an absolute monster. So to combat that drift, the experts swear by a two-phase approach. Phase 1 is ruthless simplification. You span the entire system and build a bare-bones model in just 3 to 5 days, just to get the inputs and outputs in place. Then, Phase 2 is pure iteration. Add one feature, test it, repeat. It's such an elegant solution because it forces you to start simple, like mapping out a basic office layout, before you ever get bogged down in the heavy details. The famous wealth gap model is actually the perfect example of sticking to a clear purpose. It's a fascinating simulation designed to prove just one single thing, that in a room of 100 people making perfectly fair 50-50 trades, extreme wealth disparity inevitably occurs. Because their only purpose was to teach that one economic insight, the developers knew exactly what to cut and what to keep. It really proves that a crystal clear purpose dictates how intuitive a simulation is gonna be. Which naturally brings us to structure. Here are 3 absolute best practices for any builder. First, use agent embedding.
Set up a hierarchy, like nesting a desk agent inside a room agent. It keeps the code clean and makes scaling from a single room to a whole city super easy. Second, limit inheritance so you don't end up with tangled parent-child code relationships. And third, expect to refactor. Just accept that your initial design is eventually going to need some open-heart surgery as real-world requirements change. All right, Section 4, the Paranagua Port Project. Putting theory into practice on the railway. Let's see what all this looks like in the wild with a concrete case study. This is a simulator built by a Paragon for a company called Rumo to manage the massive railway complex at Brazil's port of Paranagua. 30%? That is a massive operational footprint. Rumo handles 30% of all incoming goods at this major port, mostly exporting agribusiness products like grain and sugar. With new terminals and huge investments coming online, they desperately needed a way to study their rail capacity. Because at this kind of scale, efficiency isn't just nice to have, it is absolutely critical. To manage the chaos of random train arrivals and all that dynamic routing, the team tracked 5 specific KPIs. They looked at cargo throughput, dwell time, track utilization, locomotive workload, and the formation of outbound trains. By monitoring those specific metrics, they could safely assess the capacity of totally different operational scenarios without ever moving a single real-world train. And here is one of the platform's absolute superpowers: parallel execution. The system lets the team set up a massive batch of complex routing scenarios fed simply by Excel CSV files. As you watch it, green dots show completed runs, yellow is current, red is pending. You essentially set up your inputs, hit run, go grab a cup of coffee, and return to beautifully consolidated data that is ready for high-level decision-making. Finally, let's wrap up our framework with Section 5. Building better models together. As these simulations scale to encompass entire global supply chains, you inevitably have multiple developers working at once. The main challenge? Collaborating without accidentally overwriting each other's work. You know, when teams collaborate at this scale, there's a very right way and a very wrong way to do it. The bad way is throwing everything onto huge flat flowcharts and relying on manual file sharing, which inevitably leads to disastrous code conflicts. The good way, the industry standard, utilizes agent encapsulation, branching via GitHub, and totally separating the visual UI from the functional logic. That object-oriented approach saves countless hours and massive headaches. Because AnyLogic is writing Java code in the background, 2 people touching the same element can completely break the model. So, master developers follow 4 golden rules for Git collaboration. Commit your progress every 15 minutes, always branch off the master line. Update your branch before asking for a review. And crucially, never have 2 developers work on the exact same agent type at the same time. Assigning one person to the visual UI and another to the functional logic ensures seamless teamwork. As we wrap up this explainer, I want you to consider the massive potential we've just uncovered. Whether you are routing trains in Brazil, mapping a global supply chain, or literally just figuring out the best layout for your office, what chaotic parts of your own business, or even your life, would you simulate if you could safely hit fast forward and see the outcome before taking the leap? Keep exploring, and thanks for joining me today.